start doing 8.4 logarithmic functions. This is going to be a new topic for you, and it may take a little while before you build some intuition to have kind of a good sense of what it is. But basically, what a logarithmic function is it helps you to answer this question of if you have some base that's raised to some variable that equals some number. Logarithms help you solve for x. Because, I mean, how would you do this right now? Of course, right now, you could say, well, I know 2 to the second is equal to 4, and 2 to the third is equal to 8. So 2 to some power, I guess, is equal to 6, and that's going to be a power that's between 2 and 3. But, without having some mechanism for actually solving for x, it's really hard to kind of figure out what that is. It turns out that x is equal to 2.585. And so in other words, 2 to the 2.585 equals 6. Well, how would you figure that out in general? You don't have those tools at this point, to do that, and that's why we need logarithms in order to do that. All right, so let's take a look at the green box that is right below, the first, that top paragraph that we just looked at on page 486. And let's read that together and sort of talk about it. Okay, definition of a logarithm with base b. So keep in mind that when we're talking about logarithms, it's always going to be in connection with a particular base, okay, of an exponential function. So it's in connection with a particular base. All right, so it says let b is always going to be positive. Your bases are always going to be positive. Okay, so they're always going to be, I should just make this greater than 0, and then y is always going to be also positive, and also your base is never going to equal 1, because why? Because if your base is 1 and I raise that to, any kind of power, what am I going to get? I'm going to get 1. So it's not really an exponential function, is it? So they're limiting that. So that the base can't be 1, but it has to be positive. All right, so it says the logarithm of y with base b is denoted by log base b, is how you say it, y, and is defined as follows. So it's saying log, okay, and that's just short for logarithm, of a base, so it's like a little subscript b of some number y equals x, okay? If and only if, all right, do you guys remember this from geometry? The biconditional, so this can go backwards and forwards, right? If and only if b to the x equals y. Okay, so in other words, what we're saying is these two statements are saying equivalent things with different notation. One is in log notation, one is in exponential notation. So what this is saying is that if I take the base, here it is, for the logarithm of some number here, then the answer to this logarithm is the exponent, okay? So let's do something, let's put some actual numbers on here that we know something about this. Okay, so let's say we say 2 to the third equals 8. If I were to write this in log form, the equivalent, okay, they're saying the same thing, I'm going to say the logarithm, what's my base here? Well, it's 2. Of 2 of the number 8 equals 3. So in other words, it's saying, what power do I raise the base 2 to in order to get to 8? Well, I would raise 2, the exponent would be 3, right? And that's really what you're doing here. You're answering the question of what exponent will give me that number. All right, and of course the expression says log base b is read as log base b of y, okay? All right, so let me clear this page. All right, let's take a look at example 1 together. And we'll work through these. Example 1, okay, A. So what they want us to do is they want us to look at the logarithmic form and then translate it into the exponential form. So these are all equivalent expressions, but one is in log form. So this is log base 2 of 32 equals 5. Okay, so if I were going to write this in exponential form, the equivalent, my base is 2, my exponent is 5, and that equals the argument of the logarithm here, which is 32. Okay? B, log base 5 of 1 equals 0. All right, so that's saying that I'm taking the base of 5. What exponent am I raising it to? 0, and that equals 1. Okay, these are saying exactly the same thing. All right, C, logarithm base 10 of 10 equals 1. All right, so what's my base? 10. What's my exponent? 1, and that equals 10. Now, FYI, this is actually not very standard. What you're going to discover is that the common log is base 10. And kind of like the square root, you know how we don't put an index on that? We usually don't put an index on the common log. So you don't really see this ever after this. Okay, it'll just say log 10 equals 1 is what it would say. But they haven't introduced common log yet, so they will in a few minutes. All right, and then D says log base 10 again of point 0.1 equals -1. Okay, so what's my base? Still 10. What's my exponent? -1, and that equals 0.1. Okay, and then lastly, E. Okay, my log is, the base is 1/2, and it says of 2 equals -1. All right, so in exponential form, my base is 1/2, my exponent is -1, and that equals the argument of the log here, which is 2. Okay, now let's take a look at the green box there at the bottom of page 486. It says, let B be a positive real number such that B does not equal 1. Okay, and it says this. It says log of any sort of base, B, of the argument 1 equals 0. Why is that? Well, because any base, as long as, base of, not equal to 1, raised to the 0 power equals 1. Okay, so this is, so anytime you see a logarithm equal to 0 and the argument is 1, then you know that you're really raising something to the 0 power. All right, the second thing says log, if I'm taking the logarithm of some base of the base equals 1. Why is that? Well, because if I take that base, raise it to this exponent, I'm going to get B. Okay, so anytime I'm taking the logarithm of, relative to some base of the same number, same base, I'm going to end up with 1.